Assalamu alaikum. Bismillahirrahmanirrahim. Today, on which topic we are going to discuss? It deals about the numerical differentiation, what it is and how we can apply it on solving the different questions in numerical methods field. So this is the major topic on which we are going to discuss. Those who have seen the previous lecture on interpolation, so here we are going to start writing first of all the interpolation formula, because the numerical differentiation formula is derived from the simple interpolations formula. And if you remember, in the interpolations video, there we have developed the formula under the title of the Newton's forward difference interpolation as well as the Newton's backward difference interpolation. So here we shall be deriving the formula by using the Newton's forward difference interpolation formula, and the backward difference will be, we can write down similarly. So here we give only the derivation of the Newton's forward difference interpolation formula for the numerical differentiation. So the title of the topic is the numerical differentiation by using the Newton's forward difference interpolation formula. This is the title of the topic on which we are going to discuss. So this is the title. We are using here the Newton's forward difference interpolation. If you remember, for the case of the Newton's forward difference interpolation, we have derived the formula in the case of y is equals to y0 plus p times del y0 plus 1 by 2 factorial times p minus p into p minus 1 times del 2y0 1 by 3 factorial times p minus 1 p minus 2 and delta 3y0. The next term is 1 by 4 factorial p minus 1 p minus 2 p minus 3 delta 4y0, and one more term we write on here, p into p minus 1 p minus 2 p minus 3 p minus 4 into delta 5y0, and there can be many more terms. So this is the formula which we have derived in our previous lecture for interpolation. Our similar kind of formula we also have derived written down directly for the backward difference interpolation, and there was a slight difference, and the difference was only of the notations of y0s as well as the operator and the minus sign there. Otherwise everything is the same. Now from here we shall be constructing or deriving the formula for the numerical differentiation. Because we are using the forward difference, that's why the title contains it, forward difference interpolation by using the Newton's formula. The first step in order to derive it will be just expanding the brackets. Means you have to take the product of these all to split them into a single bracket. So here we get y0 plus p times del y0 1 by 2 factorial times p square minus p into del 2y0 plus 1 by 3 factorial, and whenever you take the product of these three terms, you can do it very easily. So the result will be equals to p cube minus 3p square plus 2 times p into delta 3y0. Similarly, the product of these four terms gives you plus 1 by 4 factorial into p4 minus 6p cube plus 11p square 6p and then 4y0 and the last term is over here. If you take the product of all these terms, so this gives you 1 by 5 factorial times p5 minus 10p4 plus 35p cube minus 50p square plus 24 times p and delta 5y0 is there. So this is just the expansion or expanded form of the interpolation formula. After doing this, the next step is, let me erase it from here. Okay. The next step is to differentiate, because we are deriving the derivative formula. So here we have to differentiate this. This is a polynomial and we are going to differentiate it. This is not a part of the polynomial here so far. So we have to find now dy over dp. Means you have to differentiate the whole polynomial with respect to p. On differentiating, because the first term doesn't contain any p, so it gives you 0. From the second term, there is 1p, and differentiating with respect to p gives you delta y0. Plus 1 by 2 factorial means 1 by 2. And within the bracket, these are the two terms. We can differentiate it with respect to p. So we can write down 2 times p minus 1. And the outside delta 2y0 will be there. Plus 1 by 3 factorial gives you 1 by 6. Inside the derivative of these three terms gives you 3 times p square minus 6p and plus 2 into delta 3y0. So far we have differentiated up to this level with respect to p. Now you have to differentiate this with respect to p, and 1 over 4 factorial is equals to 1 by 24. On differentiating this, we get 4 times p cube minus 18 times p square plus 22p minus 6 into delta 4y0. So this is the derivative of this term. And similarly, for the last term, we get 1 over 120, and 5 factorial is equals to 120, and this gives you 5 times p4 minus 40p cube plus 105p square 100 times p and plus 24 times delta 5y0 and so on. So this is the derivative so far we obtain from here with respect to p. So you can check it. If you find any error, you can remove it at this stage, as this will persist and go on. Okay. Now there is no more need of this. We can erase it from here. Basically, we are looking for a formula which is going to assist us to find out the derivative. So here we so far obtained dy over dx. Basically, the task is to find dy over dx. So here we use the chain rule, d over dx into d over dp into dp over dx. So here I have used the chain rule. Now you can see here, this term contains two quantities. Sorry, this is not the case. I'm sorry for that. This is dy over dp into dp over dx. This is the chain rule we are using here. And here you can see the term containing dy over dp. This can come from here directly. we can substitute the value of dy of db from this polynomial